So our third presentation this afternoon is the presentation which has been selected in this year's practitioner-led category. And this was responding to a research question which was set by Palmer's Chief Performance and Analytics Officer, Mathieu Lecomte. The presentation which was selected was picked by Alex Sattari, who proposed a method of identifying player styles through applying a non-negative matrix factorization with the aim of uncovering common passing, receiving, and high-intensity run patterns amongst all players in a data set. The aim of the work is to identify players who are stylistically similar, which can then be applied to further optimize a recruitment department's profiling of players. And it has been created, like the first presentation today, using a combination of event and tracking data. So Alex has flown over from Calgary to deliver his talk today. He possesses a PhD in geophysics from the University of Calgary, and more recently has worked as a postdoctoral research associate in sports analytics in Sweden. So yeah, please give him a big hand as welcome Alex to the stage.
Thank you. Hello, everyone. I'm Alex Sattari. I'm a football data scientist with a background in physics. And I would also like to thank the Stats Perform and Parma for supporting of this project. Please accept my apology if I have to cough. My allergy is kicking in really hard. Today I'm going to talk about identifying football player playing styles through the analysis of passes, receptions, and high-intensity runs for optimized recruitment profiling. So basically, what's the question we're trying to address? So the question we're trying to address is how can we optimize finding football players with similar playing styles in the recruitment profiling process? As we know, conventional roles these days cannot really explain the intricacies of how player moves or how they pass or how they're connected with each other. And one example of it can be inverted fullbacks. So inverted fullbacks, very complicated players, sometimes can be midfielders, sometimes even attacking midfielders. So we would like to come up with a model to be able to grasp these patterns in players. So we would like to analyze their spatial connectivities through the passes, receptions, and high-intensity runs, and come up with their style. So the key takeaways from this presentation is that we demonstrate a method of finding players' playing style with an interpretable and quantifiable way, and then we show that we can use this method and find similar players with a similar pattern, and we can also show that this method can differentiate between these the detailed differences in passing style and running styles of players, and overall that this method can help teams to be even more precise and targeted in finding players who meet their tactical needs and synergize with their current squad. So this presentation has two parts. First part is that we go through a method and we figure out how to identify individual football players' style. And in the second part, we try to compare some football players and then figure out a method that how can we find similar football players based on their style. So let's just talk a little bit about the current state of player style analysis in recruitment profiling pipeline. Has many numerous stages of analysis. So one stage is that we want to figure out the style of the football player that we're trying to recruit and if he is a good tactical fit or for our team, or how is he doing and how is he going to do in our team. So typically this is done through the key performance indicator style analysis. So we look at the key performance indicators of players, plots like this, and we try to find players, we find an ideal player, or if we want to replace a player in our team, we figure out their KPI style, and then we look for similar players in other teams with the similar KPI style. So KPI style is basically the statistics of different actions done by the player. So, but there is something missing in the KPI style, is that the positioning of those actions. So we don't know what those shots or tackles or passes are happening on a football pitch. So to grasp that, we can go one step further and analyze the spatial heat map style for different actions of a player. For example, we can look at players' passing heat maps, tackles heat maps, or different sort of actions, and then find similar players in other leagues with the similar sort of heat maps as well. So far we can find players that they have similar KPIs and similar heat maps. However, we still are missing information, and the information we're missing is the spatial connectivities. For example, passes, they have an initial position and they have an end position. But the heat map only focuses on the beginning or the end and shows kind of an average positioning. We miss this connection. So we would like to go even one step further and find the style of a football player based on all these spatial connectivities through passes, receptions, and high-intensity runs, in position high-intensity runs and out-of-position high-intensity runs. So spatial connectivity style. So how can we come up with a model to analyze spatial connectivity style? We need a method. So here I'll walk you through the method that is going to capture the patterns in the passes, receptions, and high-intensity runs by a player. So first step is that we collect the data for all of our individual players. So we collect their passes, receptions, and all of their high-intensity runs. And after we collect the data, we would like to find patterns in all these passes, high-intensity runs. But we cannot, so we have to organize this data in such a way that we are being able to find patterns in it. So how do we organize this? By building networks based on these passes, receptions, and high-intensity runs. And how do we build these networks? So here is an example of how we build high-intensity run network for a player. And high-intensity runs have been assumed a continuous run over 20 kilometers an hour for a player in this project. So let's assume that we have a player, and he had 3 high-intensity runs, in-possession high-intensity runs. Each run has a starting position and an ending position, which is shown by blue dots here. So first we map these runs on a football pitch, then we add a grid on top of it, and as we can see, we can assign a cell to the initial position and ending position of all these high-intensity runs. So for example, at the bottom, you can see there are 2 high-intensity runs that they share the same initial cell, and they also share the same ending cell. Then what we do is that we collapse all the runs into one vector if they share the same initial and the same ending cell. And the thickness of the arrow shows how many runs are in those connections. For example, the bottom shows that the thicker arrow because there were 2 runs between the corresponding cells. And then we keep adding more and more runs into this. Then we come up with something like this, which is, for example, in possession high-intensity run of a player. It shows that he does a lot of forward runs into the left half space and diagonal runs into the box as well. So then, after we built these networks for all of our players, we need to merge all these networks together. So far, let's do a recap. So first, we collect the data for all of our players. Then we build the networks for all of our individual players. Then we have a data set that we merge all of their networks together. Now we need a math magic method to kind of find the patterns from all of these data that we have. And what the math method is the non-negative matrix factorization, or NMF. So here I'm going to show you an example, a schematic example of what NMF is. So let's assume we have a data set of 300 bookshelves with a lot of books in each one of these bookshelves, and we would like to find and identify the style of each bookshelf. So what we do is that we apply the NMF techniques on all these bookshelves data sets with all the books inside and all the text inside the books. And then let's say that our NMF finds common patterns in these bookshelves for us: science, history, spirituality, math, and literature. And therefore, after that, we can find and identify the style of bookshelves based on these patterns. For example, my bookshelf's style is that 50% of the books are science, 20% are history, 15% spirituality, 10% math, and 5% literature. So now let's go back to our networks. So the networks here is basically the bookshelves, and we want to find the style of our players based on some common patterns inside these networks. So when we do this NMF analysis, the first output is that we come up with these common patterns. So you can see some of them there, like zone 14 breaks or right press pattern. And then the other output of the model is that, so these are the patterns, the common patterns that we find. So the left side A shows the common passing and receiving patterns. There are 14 of them here, and there are 12 patterns for the in-possession high-intensity runs, and there are 8 patterns for the out of possession high intensity runs. Then we can use this pattern and come up with the profile of a player, which is basically the percentage of every single of these patterns that built that player, built the player network. So now let's go through an example of a player and see if we can understand, look, if we can study this example player A. So for example, we find that for player A's passing and receiving pattern, this is his style. So the darker the color is, the higher the percentage. The name of the pattern is written underneath. So first thing we can see is that the highest percentage of his passing is coming from the left midfield pattern, 41%, which looks like this. So it's a lot of short passing and receptions in the left midfield. And we can also see that 15% of his passes and receptions are coming from the center attacking midfield, which is pretty significant for the CAM pattern, even though it's a low number. However, the CAM pattern is about a lot of passes and reception in the zone 14 area, so it's pretty significant. And also 13% of his passing pattern coming from the forward pattern, which is a lot of reception in the box and in the zone 14. And we can also see that 21% of his passing pattern coming from the right wing, however, 7% from the left wing. And we might say, oh, if he has a lot of passings in the left midfield, how come sometimes he has more passing pattern on the right wing? So that's due to the switching. And right wing pattern is about sending the ball from the corners into the box. So this player is more focused on the midfield for making play. So it's a forward, probably a forward playmaker, but sometimes switch to the right and then help sending the ball into the box. Now let's look at his in-possession high-intensity run patterns. So first thing we can see that 51% of his run patterns are coming from the left half space break. And then how does left half space break look? It looks like this. So it means a lot of forward runs and diagonal runs into the left half space. And we can also see that he has 33% of zone 14 break pattern, which is a lot of forward straight runs from the midfield into the zone 14. So this player shows that he's probably a forward attacking, forward playmaker, that it does a lot of in possession runs forward into the half space and zone 14. And now let's see how does he contribute to defense by looking at his style of out of possession high intensity runs. So as we can see that 52% of his out of possession high intensity runs comes from the high press pattern, which looks like this. It's a lot of forward straight runs into the opponent's half, and 26% comes from the wide left press pattern, 16% comes from the center mid press pattern. So this is probably a forward playmaker, focus on the left, sometimes switch to the right, send the ball to the box, and usually basically help the defense only by pressing, not by recovering. Now let's add another player, player B, to see that if our model can kind of show the differentiation between these two players. So player B, here we can see his receiving pattern, and the bottom shows player B. He has 53% of the center midfield pattern. And comparing to the player A had almost zero. So player B is almost probably a midfielder and not really a attacking midfielder or forward. And he has 21% left mid pattern and 11% right mid pattern. So it's a midfielder which is probably more focused on the left side. Now let's compare their in possession high intensity runs. So player B, we can see that player B has only 9% of left half space break compared to the 51 of player 1, and only 8% of the zone 14 break compared to the 33 of player 1. But he has more of the build-up runs. So it's like center mid build-up, 24%, right center mid build-up. So it's more of a midfielder that helps building up and not really contributing to the attack. And here, let's look at their out of possession high intensity run. So this shows their defensive behavior, and we can actually, it's consistent with what we so far know about both of them. So player B, most of his runs are all about the recovery run. And if you look at the press, so for example, high press, he has 0%. Or wide left press, he has 22%, and wide right press has 4%. But he's mostly focusing on the defense. Center mid defense is 25%, or center mid recovery is 34%. But player A had 0% recovery. So this is probably a defensive midfielder that really goes back and then recovers the ball. Now the second part of this presentation is that now we figured out that we can find these patterns or style of football players. How can we find similar players based on this method? So first thing is that we have two ways to do that. So the first one is that sometimes you have an ideal player in mind, and you would like to find a player based on that, or sometimes you have a player in your current squad, but you want to adjust that player to a player that you want, and then look for a similar player in your data set. So in the first way, so let's say you specify an ideal player, I don't know, Mbappe, Ronaldo, someone, and then you find the patterns of that player in your data set. And after you find the pattern, you have to map that player into this 2D map, which I call it a player similarity map. So this player similarity map can be built using some dimensionality reduction method. But you can think of it as a 2D map that every point inside this is basically corresponds to a player in your data set, and the distance between the points is a measure of their similarity. So the closer the points are together, they're more similar. So you map the player that you want into the similarity map, which is this red point here, and then you search through the vicinity and you rank the players based on their distance to this ideal player. So that will be your short list of players. So you go through that and you analyze them. And the second way is that sometimes, let's say you have a player in your squad, and in this case, let's say it's a fullback. So this is a passing pattern of the play in your squad. So it's 88% left wing and 7% left mid. So this is basically a fullback or left wing back that is just focused on the flank and doesn't really contribute in the midfield. So maybe you want him to contribute more in the midfield, so you can decrease his 88% by 20, and you increase his left mid pattern by 20. So technically, you're turning this fullback into an inverted fullback by adding more contribution of passes in the midfield. So the rest is kind of the same. So you map this player that you already adjusted into this player similarity map, and then you go kind of search through the vicinity and you rank the players based on the distance, so that will be your short list. So some other application of this method is that based on these player styles, you can track the tactical progress of players in your team on a weekly basis or a monthly basis. So you can see that how do they contribute, how do they pass, how do they move in different games. And also you can use this to devise tactics that leverage the strengths and mitigate the weaknesses of your players. So for example, you can see the style of your player, you can show it to the coach, and the coach maybe thinks like, oh, this is not what I want from him to do, so you can advise the player to change. Or sometimes maybe coach sees the style of players and change his plan based on what his player can do best. And also you can analyze opposing teams' players as well. So what's next is that based on, so here we analyzed high-intensity runs, but every single high-intensity run is not the same in terms of context. So they might be running behind, they might be overlapping run, they might be different sort of contextual runs. So the next phase of this research will be that we find these networks on specific contextual runs, and then we can find even more detailed style of players. And thanks for your attention.